Welcome back to another chapter of tutorial. And in this case, what we're going to be looking into is to how we can create like speed control. So every time we want to show the wheel spinning forward or backwards, we just want to create a control that not only controls the movement of the wheel, but at the same time, you can also use this to increase the speed of your cars. And to do this, we just have to basically create a control for that. So let's right click into our space here and add another control. Rename this to speed control. Let's give it a different color. So make it yellow. And I'm just gonna parent it with our control space null. And what I'm going to do now is to come up with some shape. So in this case, we are actually going to use like a double arrow. So I'm going to keep it this way. And also, let's increase our size. Let me show that you always, if you want to use all axes at the same time, try to use the lock pad here to lock it and then change this. So what we'll do next is we want to have this ability not just to control, but at the same time be able to use one of the floats for this to be able to access and change the speed according to the direction of the arrow that we're aiming with. So in this case, what we're trying to do is not to use all the axes of the vector. We're just going to use only one. In this case, it happens to be x value. So in this case, what I'm going to do is to also make sure that I change my Euler transform and set it to float. And at that case, we're using x, which is perfectly fine for this example. And what I'm going to do is also restrict switching here so that it blocks from anything else there. So, and I'm going to compile it. And then if I right click and look for get control float, and what I'll do, I'm just going to use this. I'm going to use the speed control here. And I'm going to start creating this little functionality for the wheels to spin. So in this case, what I'm going to do is to add multiply. We're going to connect the float here. And I'm going to copy once more, place it there. And I'm going to use accumulate time. This will basically use the time every time it moves, and it simulates through the time value that it's playable during the playtime. So in this case, also works according with the time within Unreal itself. So that's another thing, and this helps to also control the speed accordingly within the time when you start animating later. So, and also another thing I want to do is add from Euler, which is the angle that we're going to use to make the rotation of the wheel spin on the accordingly, depending that how the arrow's direction is pointing. Then the direction also around its axis will make the wheel spin. So in this case, we're gonna use a UI value because that's what it should be. So in this case, we're gonna also introduce this function called half pi. That's basically more of like a parameter which actually returns pi value and multiplies 0.5. And the point of this is to make sure that the wheel spins properly as well. So it's more accurate in this case. So this one, as you may notice, b value is left out, and this is what we're going to use this multiply the speed control of it. So we can actually set it to maybe higher value, and we'll test this out in a bit. Another thing now I want to actually do is also we need to make sure it offsets the transform of the wheels that we actually go and work with. So in this case, I'm going to right click and look offset transform. I'm going to duplicate it 4 times for now. So that's it. And also, let me check something very quickly. And I think we are on the good direction. So yeah, so we're going to keep that as a balance, but we need to now define what actually we want to spin. So in this case, we're going to be spinning all the wheels. So as you follow this, we're just going to add all of them. And we're gonna actually do the same thing, not to forget, with calipers. But because with calipers it's gonna be a bit different approach, but this is something I'll get to it in a minute. So let's just first connect these with our, in this case, wheels here. So let's get this result and connect this to our rotation, since we are using the rotation values of our wheels to spin. And I'm gonna connect this with all the rotations of the transform. And I'm going to then finally connect this into one. So I'm gonna pick up the B value from the sequence and I'm gonna plug this in, and let's do the same thing for the others too. So let's just do that. And let me compile and test it out for now, see what happens. So if you can see on the little preview menu here, if I move this, then technically I have my wheel spinning. But as you may notice, something's wrong. Well, the reason why, because the calipers are moving at the same time with them, but that's not right. So we just have to do the same thing what we've done, but instead of connected to rotation, we're just gonna have to leave them at transform, as it only setting to be working at translation mode, not in the rotation mode. So let's just use these what I have already duplicated. So I'm gonna replace with calipers for each, and this would be, and this is gonna be all the calipers we have. So just to make sure I have all of it, yeah. So I have L for RL, and I'm going to connect it here. Okay, now that's also. And also I noticed one thing is also make sure you are turn off the propagate to children, so that doesn't sort of like depend on the values, especially the skeletal mesh components to each bone. So I'm gonna also, that helps to remove this, the constraints. Now it's fixed, so that's perfect. And that's pretty much for now with this whole setup we have. And also another thing I'm gonna have to do, which is also add the valuation as a control to work with the backward driving. So in this case, I need to add some limitations for the offset translation. And to do this, of course, like we did last time, is to set minimum and maximum. And I'm going to set my minimum to 1 minus 100, which is the 100 units, and 100 here. Okay. Let me test this more. So let me just see what happens if I set to 10. Yeah, that's actually much better. So that will be pretty much easier to not just adjust, but also control the speed and whatever the speed you want to drive with during the animation. So just to test more out, so as I do this, and I just, yeah, it works perfectly fine. Cool. Awesome. Okay, so let me just set all of them. Let me just organize a little bit so that it doesn't look too awfully all over the place. I'm going to see if I can move this into something like maybe a function. So okay, just for now let's leave it as it is. Yes, so that's okay. And right, okay, so I'm gonna, okay, let me just place them all around, and then I'm gonna move this out of the way, Control C for comment, and I'm gonna call speed control. So I'm gonna increase that so that's more visible, change to something more. And the next lesson we're gonna work on something exciting, where we're gonna use a control root for the entire car, but we're actually going to use suspension. So what I'm trying to say is that We are going to work on the suspension physics, which you can actually do this inside module as inside control rig. And I'll show you how to do this step by step. And that's where we're going to basically end our tutorial. And this is where it's going to be slightly complicated, because that requires a bit, not only maths, but also slightly some path understanding. And of course, don't you worry, we're going to go through this together. So that's pretty much it. Thank you all, and see you guys in the next lesson.